This video is about how to use Hamilton's method to solve an apportionment problem. So remember, an apportionment problem is a fair division problem where players are entitled to differing percentages of a set of goods, but must receive a whole number of items, and all items are identical and indivisible. Our standard problem is dividing up the seats in a House of Representatives or some sort of government. Remember, the standard quota is the number of seats that a state will receive in the apportionment, but the problem occurs when standard quotas are not whole numbers. Since a state cannot receive a fractional seat, we have to figure out how to handle this. So in this video, I'm going to talk about an idea that Alexander Hamilton proposed. You may have heard of him. He was kind of involved in the creation of the United States. So this was his idea about how they should apportion the seats in the House of Representatives. Now, it was not adopted until 1852 because George Washington didn't like it, but eventually it was used from 1852 until 1911 when they switched to a different method after that. So Hamilton's method has 3 steps. The first step is to find each state's standard quota. We've done this before, so this isn't too bad. But there's this little note here is that you need to write down as many decimal parts as needed to distinguish between the fractional parts. This will make sense in a minute. Step 2 is to give each state its lower quota and then find the total. If that equals the number of seats that we want to hand out, we're done, although that's not terribly likely to happen. Step 3 is that we distribute the remaining seats one at a time to the states in order from the largest to the smallest of the fractional parts. That's why in step 1 it says that we need to write down as many decimal parts as needed to distinguish between the states. So let's do an example here. I have 4 states and their populations are listed here. There are going to be 20 seats. I probably should have said that. I have a feeling I did in a previous version of this video, but that's okay. In this example, there are 20 seats to be handed out among 4 states. Their total population is 3,000. So we'll find the standard divisor the same way we always do, by taking the total population divided by the number of seats, which is 150. And then we get the standard quotas by taking the population divided by 150. So 585 divided by 150 is 3.90, and so on. Divide each population by 150 to get the standard quota. And this does add up to 20. It might not due to rounding errors, but don't stress about it a whole lot. So as you can see, I have carried each standard quota out to 2 decimal places because I can tell them all apart. So the next step is to give each state their lower quota. Remember, the lower quota is just the whole number part of the standard quota. And then we find the total, which is 17. So I need to hand out 20 seats. So far I've only handed out 17, so I have 3 seats left that I need to hand out to the states. So I'm going to go back to the directions. Step 3 says to distribute the remaining seats one at a time to the states in order, largest to smallest, of the fractional parts. So I've modified my table here, and I've just listed the fractional parts of each state's standard quota. This makes it a little bit easier to look at. This is optional. You can do this if you like or not. But what I need to do is identify the state that has the largest fractional part. And that's state A with 0.90. So state A is going to get 1 more seat. If I add these up now, my total is 18. So I have 2 seats left. So now I look at the remaining states and decide which one has the biggest fractional part. And that would be state D with 0.80. So state D is going to get another seat. Add up the total, I'm up to 19. I have 1 seat to go. So I look at my 2 remaining states, states B and state C. State B has the higher fractional part at 0.66, so state B is going to get another seat, and this brings my total up to 20. I find it helpful to make the fractional parts all have the same number of decimal points. That way it makes them much easier to compare. Again, 90 was the largest, then 80, then 66. So that's how I knew who got the extra seats. And that's how you do Hamilton's method. It's not too bad. It just can be a little bit fiddly because you have to be very careful with reading off the numbers.